Java fork join pool. Let's go through the intuition of what is it and how to actually use it and what use cases does it suit. So in Java, we can create thread pools. We can create threads. We can create them by ourselves, or we can use the executor service. And a few patterns have emerged for different kind of workloads. If we want all our threads to be as busy as possible, then there is one kind of pattern. If we want a thread to wait on a connection, then there is another kind of a pattern. Many of these patterns appeared in Doug Lee's great work, and he has an amazing book on Java threads if you want to get deep inside Java threads. So as it sounds, the ForkJoinPool is just a framework, just a set of patterns on how to use multi-threading in Java and to optimize for the threads that we used to always have a work to do. Let's see how it's working. So it's from Java 7, the ForkJoinPool. It's based on Doug Lee's great work, and as it sounds, it's break our tasks into smaller tasks, and then these tasks into smaller tasks. I think until we can optimize all the work and get all the small tasks to work. Let's say that you have a list of files and you want to process each files. This sounds great for a ForkJoinPool. Just go to the directory and assign a task for each of the files and run the work. So ideally, we won't have any worker thread idles. And this is because one of the main points in ForkJoinPool is that threads can still work one from another. If one thread is waiting, no reason for another thread not to still work, because we said we split all the tasks in between them. Okay, so the classes that we see when we use the ForkJoinPool is one. Obviously, the ForkJoinPool, this is the executor service, this is the actually a orchestrator of all the threads that we have. In order to create this executor service, this orchestrator, we call ForkJoinPool equals new ForkJoinPool, and then we give it in parentheses a parameter, the parallelism, how parallelized we want this, but note that the pool can adjust its size. We just specify the initial number. Okay. Then, after we have a ForkJoinPool with simply this new ForkJoinPool, then we start assigning tasks to the ForkJoinPool. Each task has its interface. It's called a ForkJoin task. So we have a ForkJoinPool and we have a ForkJoin task to provide to the pool. Each such task has a few methods that we could call in order to submit tasks. One of them is the execute, asynchronous, invoke, sync await, and submit. 3 tasks. We can call the ForkJoin task these 3 methods: is done to when the task is complete, is completed normally, completed without cancellation exception, and is completed abnormally, it was cancelled. Now, how to use the ForkJoinPool? First, we create a specific task. For example, a recursive task. This is the object, recursive task. And then we implement the compute method. In this compute method, we place the code that we want this task to execute. This is like the run method of threads. However, note that in this compute task, we can create actually additional tasks inside it, and that's the whole point of ForkJoinPool. These additional tasks could be also recursive tasks. This is why it's called recursive. And in order to create them, we call task.fork. So we basically get back to the Unix forking, the concept of forking. And we put all of these tasks inside a list, inside our main recursive task. And finally, we loop this list of recursive tasks and call join over them in order for all of them to complete. And then our task would also complete. So it's a hierarchical recursive execution. So we said that we use the ForkJoinPool, where we create a new ForkJoinPool, and then we call the pool dot execute. Execute my task 1, my task 2, and each task can fork into additional tasks. So the main points, let's summarize this. The main points of the ForkJoinPool is that threads can still work one from another. Therefore, we optimize for all the threads not to be busy all the time. Tasks can create the subtasks. This is why it's called the ForkJoinPool. We fork tasks into additional tasks, and then as a result, we wait for the task to join, and then the threads maximize its runtime. So this was the brief summary into Java fork join pool.